Hello, everyone. My name is Martin Jarrold, the Vice President of International Program Development with the GVF. And it's my great pleasure to welcome you today to our GVF Focus Member in Focus session. And it's my very great pleasure to be joined today by representatives of ALCAN Systems. And we have with us the Chief Executive Officer and co-founder of ALCAN Systems, that is Dr. Onur H. Karabey, and also by Mustafa Bülbül, who is the Business Development Manager with ALCAN Systems. And very briefly, to give you a little more of an introduction to Onur and to Mustafa, Dr. Onur H. Karabey is one of the founders and the CEO of ALCAN Systems. He's located in Darmstadt, Germany, and also at Istanbul's Technopark in Turkey. ALCAN develops low-cost and low-power consuming liquid crystal-based phased array antennas for upcoming satellite constellations and 5G markets. In fact, Dr. Karabey invented the liquid crystal-based phased array antenna during his doctoral thesis, which he wrote at the Technical University of Darmstadt. Mustafa Bülbül is Business Development Manager at ALCAN, and he's one of the founding employees of the company. He assists the Chief Executive in business development and investment activities in the company, and he's also responsible for the company's financials. Moreover, Mustafa manages the daily operational activities of the company. Onur and Mustafa, welcome. It's a great pleasure to be joined by you today. And I'd like to kick off this GVF Focus session by asking Onur, what in your view, what in your opinion, has or have been the most significant game-changing events in the satellite industry in the course of the last decade?
Yeah. So first of all, Martin, thank you very much to you and the whole GVF team for having us here. So it's a great opportunity. We really enjoy to be a part of this discussion. So it's a lot of things are happening on the satellite industry. And if you look back the last decade, from our perspective, it's the technologies and the developments that makes LEOs happening. Yeah, so it's not only the LEO, but the developments around it. So I can categorize them into three. The first of all, the funding. I mean, the LEOs are not new. So we have seen some attempts 2 decades ago, roughly. Some are failed, some had to scale back to their business plan. And one issue was the lack of funding. But today, the situation is different. The funding is available through governments, through the, let's say, the big companies. So that's not an issue anymore. So that's one important step. And also the investors. Yeah. So there are now, we see, a lot of VCs or later stage investors joining or coming to these industries. So that's a great opportunity, great time for us. Funding is available. Once let's say the companies in the SATCOM industry, once they get this investment, they developed new technologies to let's say reduce the launch cost as well as the satellite manufacturing cost. So in the past, it was taking years to develop one GEO satellite, and it was very expensive to launch it. But today the situation is different. I mean, and it's a public information. The companies are breaking their records after each launch. So the satellite definition changed. The satellite becomes smaller, simpler, so it's cheaper. So we need several satellites, and in one launch, you can actually send several tens of satellites in one launch. So this is also great, but that's not enough to close the whole circle. The ground terminal are also needed. So we see a lot of development there. We have a lot of competition there, which is great for all of us. So we are pushing the limits in terms of the better performance, to reduce the cost, to provide better service to quality. So this is still the missing part. And if you look the LEO constellations, let's say, which are well-funded or opportunity to fund the whole constellation, they actually, because of its importance, they developed their own antenna in-house. So it's a very important missing point. So at that point, of course, ALCAN is also an important player, especially for the let's say, consumer market. Yeah. So the long story in short, all developments to make LEOs happening, I see this is the most important achievement in the last decade.
Mm-hmm. I see. Thank you very much. Now, in of course mentioning the LEO constellations, of which there are many taking various forms and various stages of development at the moment. We have those that are at the moment just filings. We have those that are in process of being developed, and we have those, of course, that have already begun to launch, and in some cases quite significant proportion of their final constellation number of satellites. So what's your view of the LEO constellations, both in general terms, and perhaps citing some specific examples of the different LEO constellations that are at various stages of development?
Yeah. So first of all, I believe they will be successful. Maybe not all of them, but compared to past, we are really believers of the LEOs, and because of the reasons I mentioned, they will be successful. So especially as ALCAN, we are the one focused on developing this missing piece. So as ALCAN and let's say our competitors become successful, they will be successful. So I would like to maybe focus a bit more past and in the future. So first of all, we know the satellite industry very well since the 50s. They played a great role in the satellite TV applications. But today, our demands are changing. So we are maybe watching the television less compared to the previous years. We are more focusing on demanding Netflix or Amazon Video-like services. So that means it's not the satellite TV, but it's still the broadband communications, which is needed, because over the time, satellite industry prove or demonstrated that they are very reliable infrastructure. And if you look to also the trends in the technology, we see that any new technology has to provide two solutions or solutions for mobility as well as to the high data rate. So the LEOs enables the mobility and also the high data rate. That's, I would say, that the more important. And if we also think about the current constellations like OneWeb, Telesat, SpaceX, and so on. So, and if we also look at FCC filings, yeah, so we see we can actually categorize those applications into two, first and second generation. The first generation, we see mix of Ku and Ka band, but the future is clear. It will be focused on Ka band and above. So we also see filings at V band, QV band. So this is physical, independent of which technology you use. The high data rate can be provided if you have only high bandwidth, and high bandwidth is available at higher frequencies. So the future of the LEOs, I believe, as I mentioned, the LEOs will be successful, but their next challenge will be in the future to go to the higher frequencies. And I also believe that there are technologies that are developing. As ALCAN, we are also developing antennas for that. So that is one aspect, the providing high data rate. And there, for example, Amazon, Telesat, they are already working at Ka band, so they can provide, independent of going, let's say, more technical details. So they have better chance because of the operating at higher frequency. And also, the LEOs, as you know, also seen as a strategic, let's say, infrastructure. So investment to OneWeb was a good example. The Canadian government support to Telesat is another example. And also we see a lot of developments in EU, in Europe. So they would like to establish their own constellation together with the key industry partners. Key industry partners means who will drive the volume. So there are some public information, and European Space Agency is driving those activities. So ALCAN is also very well integrated to those discussions. So the Europe is also looking for their own solution. So it's the first high data rate for mobility solution, as I mentioned. The second is the strategically, we should have a solution. And for example, the Ukraine SpaceX Starlink support to the Ukraine is also a good example, just to highlight it. So the satellite is actually important part of our life. And as LEOs are happening, they will be a good solution for the broadband communications, and they will open up new markets.
You mentioned new markets, and I think looking at new markets will be an aspect of perhaps of your answer to my next question. And that question is, what do you believe is the most important role for the satellite industry looking ahead? I mean, in earlier on, we made reference to 5G, for example. I mean, how the extent and the breadth, the importance or depth of significance of 5G for the satellite industry, but perhaps in a little more detail, other use cases within 5G and other use cases adjunct to 5G as well.
Yeah, it's again in the DNA of the LEOs, what they are offering. I already mentioned that the mobility and high data rate, so independent of SATCOM or whatever technology. So this is what we are demanding. Yeah, think about the mobile phones. 2-3 decades ago, the people were happy if they can send an SMS. But today, my kids are complaining if we are driving on the autobahn, if their HD video and YouTube is not working, they start to complain. So the demands are changing. So, and if you think again about the whole ecosystem, the terrestrial networks, although they do a lot of investment to 5G, starting with C-band or sub-6, going to millimeter wave like we see in US, just themselves, it's not enough. So they need a complementary technology like LEOs. I mean, LEOs offers latency similar to the terrestrial network infrastructure. So the technical compatibility will be there, is there already. So that's a great opportunity. And if you think about, again, from the mobile network side, at higher frequency, their OPEX and CAPEX will increase a lot if they want to solve everything by installing more and more base station. As higher frequencies, the signal propagation loss increases. So just roughly, future 5G millimeter wave infrastructure or base station should be at least 10 times denser than today's terrestrial network.
Yes.
As I mentioned, the OPEX and CAPEX will increase. So there are public quotes from Huawei and Nokia CEOs regarding this. So they need a technology. And at that point, satellite is actually a great opportunity. If you are outside the city center, so just having a few satellites, as I mentioned, the satellite manufacturing and launch is much cheaper now, and the technology is very reliable. So that will be a great complementary. And we already see, let's say, the developments towards this direction, like Verizon and the Amazon Kuiper project, OneWeb and British Telecom. So those are just examples I remember at the moment. So some others as well. So we will see more and more joint developments on this, and this will open up new market. I think this is the key here. Otherwise, if you only focus on, let's say, existing satellite markets, which are mainly dominated by, let's say, aviation or the military or government, the maybe 5G part is less critical unless you want to have 100% connectivity. Yeah. But if you think about that, the new markets like land mobile, so we don't have any solution for connected car. When I say connected car, there will be, again, two phases there. The one is autonomous driving, which will based on sensor, onboard computing, which will enable the car driving itself. But if this happens, what we will be doing inside the car as a passenger or as a, let's say, ex-driver, so what we will be doing? We will be, again, demanding high data rate services, and onboarding doesn't work here. You know, I mean, you can just watch videos, the film, but that's not the solution. So then we need, again, the high data rate internet connectivity. And there, the satellite will play a key role. So this is, I'm talking about the market, which is a high volume market and very, very cost sensitive market. So I believe this new LEO satellite industry will play a key role there.
Mm-hmm. Yeah, thank you. I mean, you mentioned an important point at the end there in terms of cost price sensitivities. Now, of course, in discussions about ground segment generally and antennas specifically, there has been so much discussion about the different opportunities arising from different technology bases, different technology approaches to new antennas. But of course, inevitably, as you say, the point does come round to cost, because cost relates to scale, and we need scale to address these markets effectively. So when it comes down to customer side equipment, I mean, what are your expectations with reference to average cost per terminals across the market, with reference to the new the LEOs and the MEOs? What are your thoughts on this, and what are your sort of concrete expectations, as it, or prediction, if I might go that far?
Exactly. I will give you a clear idea, but maybe before, I would like to tell a bit our background, our thinking.
Yes,
yeah? So
please.
We should look at this question from the customer or end user perspective. So they care service quality and total cost of ownership. I'm telling that because we see a lot of news or press releases that people are providing, let's say, military grade product to a consumer market. I mean, this is kind of overkill. So actually, you can do anything with your antenna. So you can provide a lot of different features. So this is possible. However, understanding their customer needs and providing technology accordingly is the key. This is given. I mean, I'm not telling something new. This is given. But we see really extreme examples on the market, which make somehow not really sense. And we are not the only one who is telling that. Some other antenna companies also highlighting this. I mean, there are good, let's say, the questions or press release regarding to that one. So when it is related with the service quality, as I mentioned, or from ALCAN's perspective, we are focusing on high volume, low cost market. Like enterprise is our starting point, and we will continue with the consumer market and eventually land mobile. Yeah. So of course, it's very critical that the service quality means the connectivity. So on smart antenna, you should have always, let's say, your beam should be always looking to the right point. The antenna should be smart to know where the signal is, that your tracking algorithm should work very well. So as ALCAN, we developed a lot of know-how, and we already make several demos to our partners. So this is one key point. The second is the total cost of ownership. So it starts from the easy installation and continues, let's say, all the time, and then and how to say that it continues with the reliable connectivity. Yeah. So it's not only that day one it works, but over the life time of the product, it should simply work. There shouldn't be any maintenance. So this is important. Yeah. So again, if I want to give an example about the land mobile, we see flat panel antennas for land mobile case, which is 2 to 3 times expensive than the car. So which makes no sense. Yeah. So that's what I want to highlight at the beginning. So as ALCAN, we are developing low-cost product based on the liquid crystal technology, and we use phased array approach. You know, the phased array is known since 1940s. So we are not inventing the antenna. They are very well known, know-how is available, but everybody knows that the phased arrays based on semiconductors, they consume high power, and they are very expensive. You need the amplifiers, which is very expensive. So we solve those two problems simultaneously by using liquid crystal technology. And our key target is, as I said, the develop low-cost product. We have an opportunity because of LC technology. And we developed key know-how within the team. Our engineering team developed a lot of know-how how to achieve this. So we can use existing liquid crystal production line. This is not that simple. So since many times, many years, we have been optimizing our design so that we can use existing production line as it is without significant investment. So this is very important. As I mentioned, our target is to go and dominate the high volume, low cost markets. So to come to, let's say, the concrete example, to our consumer products, depending on the antenna size. So they will be definitely less than $1,000.
Yeah.
And when it comes to the land mobile, so it will be less than 500. So those are our targets, and we are in discussion with the potential customers, and there is a path that we can achieve this, especially the car. As I mentioned earlier, in Europe, there are a lot of activities to develop their own LEO constellations, and the car OEMs are showing interest for that. So as ALCAN, we are not only developing low-cost smart antennas, but we had a recent announcement that we can make the transparent antennas, and we did this. So this press release is available on our webpage.
Mm-hmm.
So we develop a transparent antenna operating at 28 gigahertz. So this is done for millimeter wave frequencies, but this also proves the technology. So we can develop the same at Ka band for SATCOM, so that can be integrated onto a sunroof of a car.
Yes.
So I hope I addressed your questions. Yeah.
Yeah, just a quick supplementary one. I mean, there's always a danger in asking somebody to look into their crystal ball, but you mentioned two particular significantly price points there for different markets. What will be your projection as to when those price points would actually be achieved?
We will go into the market, the first enterprise market. So this is the immediate market. So if you recognize, I didn't give any price point on it because those are very confidential at the moment and we are in discussion, but this is not far away from what I'm telling to you. Yeah. Mm-hmm. Actually, there is also an announcement in our webpage. So the enterprise antenna unit will be 1,500 and the terminal will be 2,500. Yeah. Mm-hmm. So this is for the given size. So some customers are asking a larger version, a smaller version, so the price will scale up accordingly. But we are already achieving this target. For the consumer market, it will be ready in 26, and the car land mobile, it will be available. The first prototypes will be available, and first prototypes means production ready prototypes in 26 as well. Mm. Yeah. So, and I believe we will achieve those costs in 1 year after, because those are really volume driving markets. Yeah. So enterprise, this is an existing market. You can imagine different players, how many units that they are talking. So this is a kind of known secret. But the consumer and the land mobile, you can easily go to 1 million units. And for example, Starlink is a good example. This is a public information, the deal that they made with ST Microelectronics, and they're talking about 1 million units there. Yeah. So this is just the beginning.
Well, very, very clearly, the 2020s are going to be a very, very exciting period for the antenna industry, the ground segment generally, and the industry more widely. Speaking of the industry more widely, turning to you, Mustafa. Thinking in terms of interactions between the LEOs as they build out and the existing geostationary orbital infrastructure, what's your prognosis regarding the interactions between these different systems?
Hello, Martin. First of all, also thanks from my side for this opportunity, and I'm very glad to talking with you. And yeah, to your question, I mean, in my opinion, there are two options. I mean, first option is the combined multi-orbit service strategy in the form of a merger of different satellite operators, where geo satellites or geo operators combine services with non-geo satellites to offer the best possible services to the customers. I mean, the mega constellation in LEO and MEO can offer low latency where it is needed, and the GEO can deliver more capacity in urban areas. And for this trend, the following examples in the market can be mentioned. I mean, first, Viasat and Inmarsat happened. And also recently, it is a public information, OneWeb and Eutelsat plan to merge. I mean, Eutelsat and OneWeb, they both are based in Europe, and they can complement each other very well. And this could come to savings of maybe more than 1 billion euros, which generates advantage for them in the race for the expansion of commercial satellite networks. And the second option is the own development of non-geo satellites, like, as you know, from SpaceX with Starlink or Amazon's Kuiper projects. This strategy is also driven by Telesat with Lightspeed or SES with mPOWER. I mean, the geosatellites are necessary to offer additional capacity in urban areas, but if you put more LEO satellites, it could also bring more capacity, and this could make the future maybe of geo operators more difficult, because as already mentioned in the beginning by Onur, the trend is towards more internet TV, like Netflix, or even many TV channels can be also streamed online, and yes, this makes the LEOs very, very attractive. I mean, I also believe that the LEOs will be successful, and if they be successful, this can happen that the GEOs, the GEOs could have some differences in the difficulties in the future. And that's why I believe that GEOs should work together with non-GEO to stay successfully in the market in the long run. And if it could happen that LEOs could take over the market share of geo operators in the future because of the mentioned internet and high data rates trends.
Mm-hmm. Okay, that's very interesting. Thank you very much. Well, gentlemen, time has run away with us for this conversation today, for which I'd like to thank you. It's been interesting, it's been enlightening, and it's been great to have your particular perspectives brought into, if you like, GVF focus. So once again, thank you both, Dr. Karabey and Mustafa Bülbül, and I wish you every success, continued success with your work in developing these exciting and essential technologies for the greater good of this industry, about which we all care very much. So once again, gentlemen, thank you very much, and goodbye for now, and I look forward to seeing you face to face at the soonest possible opportunity. Now things have moved closer to what we used to call normal. Once again, thank you both very much.
Yeah, thank you, Martin. Yeah, bye-bye.
Goodbye.